this afternoon. I want to believe that students are available and they are keeping out their fingers crossed to start this class. If you are actually online now, can you please type yes? If you are available and you can hear me clearly, let me see you type yes. Because we are starting in earnest. We are starting earnest. So can you hear me? Very good. Asing Granules 3964. I can see you. Dorcas Oyebameji. God bless you. Yes. So let's come up. We don't have time to waste. I will pray that God will take care of the network for us this afternoon. Good afternoon. So you can hear me. Can you see the board? Can you see the board too? Can you see the board? 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 Can you hear me? Can you see the board? Happy Sunday to you. Okay. Oh, beautiful. So without wasting our time today, we have a lot to do this afternoon. So let us start. Others will be joining us. We want to start with partial fraction, because it was observed that partial fraction has been a subject of controversy amongst students nowadays. Many students have requested that we should visit partial fraction again. So because of the need for us to revisit partial fraction once again, that is why we are going to start with partial fraction this afternoon. Partial fraction. Now, partial fraction is a type of algebra where the main fraction is decomposed into what we call partial fraction. Let me write it properly. Partial fraction. You can see the word partial. The word partial signifies that it is not really a fraction because it has undergone some decomposition. So now we have observed 4 rules of partial fraction so far. But for the sake of this class, we are going to revisit all these rules by solving questions that are related to each rules. Okay? Now, I hope you can see the board clearly. Can you see the board clearly? Can we see the board clearly? That's the question. The problem is, can we see the board clearly? Good afternoon. Yeah, can we see the board clearly? Can we see the board clearly? Yes. Okay. You can see the board clearly? No. Yes. I think the arrangement is okay like this. Let's just let's keep the ball rolling. Okay. Now, let's look at the first question this afternoon. We are asked to resolve. We are asked to resolve. Okay, the camera should go up a little. How is it like this? Is that okay? Are you okay with this arrangement now? Fine, okay. The light is blocking the board. Better. The light is blocking the board. Which light? Okay, the arrangement should be better, right? How about like this? How is it this way? I think it should be okay like this. Is it okay like this? Is it okay? Can't see, sir. What can't you see? You can't see what I wrote on the board. Resolve. Okay. Now, let us continue, please. Resolve 6x minus 10 all over x squared minus 2x minus 3 into partial fraction. We want to resolve this fraction into partial fraction. Okay. Now, How do we resolve this? Like I said when we started, I said that we have 4 rules which could be expanded to 5 that govern partial fraction. So if you look at this particular question, what we are particular about is to check the nature of our denominator. Okay? Now let's look at the denominator. How does it look like? This denominator is a quadratic expression. It is quadratic because it has raised to power what? 2 as the highest degree. Okay? Yes. Okay? Now, so this is what a quadratic expression. So let's check whether this quadratic expression can be factorized or not. If this expression can be factorized, that implies that we are going to use the first rule. Okay? Now, let's check. Let's check. Now, solution. We factorize x squared minus 2x minus 3. So if it cannot be factorized, then we are going to use another rule. Okay? Now, how do we factorize this expression? Let's take it like this. Multiply the first term by the last term. X squared times minus 3. That's what? Minus 3x squared. Yeah. So we look for the factors of minus 3x squared. We are going to have minus 3x and x, or plus 3x and x. So this pair of factors will give us what? Minus 3x squared if we multiply them. But if we add them together, which of these pairs will give us minus 2x? It is the first one here. So minus 3x plus x will give us what? Will give us minus 2x. So in that case, we now replace this minus 2x with minus 3x plus x. So let's replace it. We have x squared minus 3x plus x, then minus 3. That is how we have changed, that particular minus 2x to minus 3x plus x. So let's pair this combination. Let's pair. So by the time we pair up, we look for the common factors there. X is common. Into brackets, that is, since x is common, you divide through by x. So if you pick x that is common, now you divide x squared by x, you are going to have what? X inside the bracket. Now you divide minus 3x by x, you'll be left with minus 3. Fine. Then plus something is common between x and minus 3. And that is what? 1. So into bracket, x divided by 1, you have what? X. Then minus 3 divided by 1, you have what? Minus 3. So with this, we're going to have what? X plus 1, then x minus what? Minus 3. So that means that we have been successful in what? Factorizing this particular denominator. So that means our denominator is what? Is factorizable. So as a result of that, the most applicable rule for us to use now is what? Is rule 1, which says that to each linear factor in the denominator of, let's say, of the factor or of the expression x minus a. I'm trying to restate the first rule for us. There corresponds a partial fraction of the form a all over x minus a, where this capital A is a constant. Don't worry, I will explain what I meant by that statement. Okay. Now that we have observed that x squared minus 2x minus 3 can be factorized into what? X plus 1 into x minus 3. Now we rewrite. Now we what? We rewrite. As a result of this, now we rewrite. Because of the space, I may have to be cleaning some things before I write others. Now, after factorizing After factorizing x squared minus 2x minus 3, we obtain what? We obtain 6x minus 10 all over. What did we obtain now? We said x minus what? Minus what? Minus what? 3x. Sorry. X minus 3 into what? Into x plus 1. I think that is what we obtain. X minus 3 into x plus 1. So that is what we obtain when we factorize this expression. So in that case now, we now introduce the constants. Now, how many linear factors do we have now? We have 2 linear factors. Why do we call this linear? Because x here has only 1 degree. The power of x here is 1. So in that case, it's going to be what's called a linear expression. The power of x here is also 1. In that case, we also call it a linear expression. So for the fact that we are having 2 linear expressions now, that implies that we are going to replace those linear expressions by 2 constants. By what? By 2 constants. So in that invariably, you're going to have 6x minus 10 all over x minus 3 into bracket what? X plus 1 will now be what? Equivalent to a all over x minus 3 plus b all over x plus 1. You may be asking me, wow, how did I get a and b? Fine. A and b are the constants that will now stand as the numerator for this pair of linear factors. Don't get it wrong. In your own case, you might have your own might be 6x minus 10 all over x plus 1 before x minus 3. If you write x plus 1 before x minus 3, you are still correct. So if you write x plus 1, that means a will be over x plus 1, then b will be over x minus 3. So the arrangements could be different, but what is important is for you to get the value of the constant a and b. Please, are we together? Please, I want to hear from. I want to get. Can you please type to me? Send me a message that you are comprehending. Are we together? Yes. Are we together? Very good. Are we together? Beautiful. So now, the next thing now for us is to what? Is to find the LCM. Don't waste your time. Just take this, multiply it by this. We have x minus 3, x plus 1 is your LCM. Okay. Now, we need only the right-hand side this time around because the right-hand side has given us what? The new prospective fractions. The left-hand side has been decomposed into the right-hand side. So we are dealing with the right-hand side of the equations. So I pick out x minus 3 and x plus 3. You know, when you're finding the LCM of different factors, you multiply them. That's why I put them in bracket each. So without wasting your time, how do we now get the results of the numerator? Fine. It's like saying that how many x minus 3 will you get from these factors? You know, this x minus 3, we cancel this out. You have only what left? X plus 1. So if you multiply a by that x plus 1, you have a into x plus 1. Okay? Now, plus. Now, x plus 1 cancelling this LCM. X plus 1 will cancel x plus 1. You'll be left with what? X minus 3. Multiply b by x minus 3. You have what? b into x minus 3. In fact, another shorter way of doing this without wasting your time is just cross multiply directly. When you have stated that these two are the LCM, now cross multiply. A multiply x plus 1, b multiply x minus 3. That is that. About that. So that means 6x minus 10 all over x minus 3 into x plus 1 is equivalent to what we have obtained there. Okay? We are very good. Very good. I'm glad you are comprehending. Very good. God bless you. God bless you. Now, what is the next thing now? We just need to what? The next thing now for us to do is to what? Equate our numerators. We don't need the denominator again because they are the same. We now equate our what? Let's equate our numerators. Let's equate our numerators. What do I mean by equating our numerators? Now, on the left-hand side, we have 6x minus 10 let B equals to or correspond to what? A into what? X plus 1 plus B into what? X minus 3. Now for now, we don't need the denominator. Okay? So we don't need what? The denominator. Let's clean this. Let's so that it will not confuse us. Let's clean this. Okay? Let's clean this. Now with this, the next thing for us to do now, we need to get the value of A and B. We need to get the value. I hope I'm not too fast. I hope I'm not too fast. Please, am I too fast, please? Are we comprehending? Am I too fast? Am I too fast? Wow. Am I too fast? Oh, beautiful. All right. Thank you very much. Thank you very much. Now, how do we get A and B? For us to get A, we have to eliminate B. And for us to get B, we have to eliminate A. That means we have to kill one to get the other one. And to kill one, we have to look for a factor. You know, a factor that will help us kill one of those constants simultaneously. Now, let's start with A. How do we kill A? How do we eliminate A here? You know, A is multiplying X plus 1. And if X plus 1 can be turned to 0, A will be dead. Yes. How? Good. Now just pick X plus 1, equate it to 0. X plus 1, let it be equal to 0. So if you equate X plus 1 to 0, you have what? X equals to 0 minus 1. So that will be what? Minus 1. So that means if you put minus 1 here, everything here will become 0. Because minus 1 plus 1 is like you are owing somebody 1 naira. Minus means debt. Then plus means given. And you gave the person 1 naira. You're not owing, so the equation is balanced. So putting X to be minus 1 here eliminates A. How? Good. Let's go there. Now we call it by what? By this cover-up method. Cover-up method. By cover-up method. Let me call this equation so that it will be clear enough. Equation asterisk. By cover-up method, put X equals to minus 1. Oh yeah, let's go there. In asterisk, in equation asterisk. Oh yeah. So we have 6 into minus 1, then minus 10 equals correspond to A into minus 1 plus 1 plus B into minus 1 minus 3. Okay? I hope we are following there. Oh, beautiful. So now minus 1 times 6, that is minus 6 minus 10 equal to then A into minus 1 plus 1, that is 0. Okay, plus B into minus 1 minus 3. Last week you borrowed 1 naira from me. This week you have borrowed another 3 naira. You are a debtor. You are, sorry to say that. You are what? You are, do I call it a serial debtor? Because you borrow 1 naira minus, this week you have collected another 3 naira. So your debt increases to 4. Okay? Now, let's try to see what we can do here. Minus 6 minus 10 is what? Minus 16. Last week you borrowed 6 naira. This week you have borrowed 10 naira. Your debt has risen to 16. 16. So this one what? A times 0 is 0. Then B times minus 4 is what? Minus 4B. Okay? Now, so we have what? 16 minus 16. Let me write it properly. Minus 16 equals to minus 4B. Then how do you now get B? Just divide both sides by what? By minus 4. Because without minus 4 being eliminated, B will not give us, we will not get the value of B. So now what? Minus 16 all over minus what? Minus 4 is equals to minus 4B all over minus 4. So minus 4 now will cancel minus 4. So you have what? Minus times minus is plus. 16 all over 4 equals to B. And so, how many 4 do you get in 16? You have what? 4. So B is equals to 4. So our answer for B is equals to what? Is equals to 4. Now that B is equals to 4, how do we get A? How do we get A? Beautiful. You just use the same principle. Observe closely something here, that for us to get B, we eliminated A. So for us to get A now, we will eliminate B. Let's try that. Let's try that. B is what? Is equals to 4. Don't forget that. B is equals to 4. Let's write that some here. Let's write that somewhere. B is equals to 4. Okay. Now, going back to equation asterisk. Now, we want to eliminate b now. And b has a factor x minus 3. What value of x are we going to put here for the whole expression here to be 0? It is 3. How? Good. How? Just say x minus 3 equals to 0. Okay? So, now when x minus 3 equals to 0, that is the whole expression here, x will equal to what? 0 plus 3. By the time you transfer 3 here, minus will change to plus. So, x will equal what? 3. So, if you put x to be 3 here, everything inside the bracket will be 0. And b times 0 will be 0. So, b will be eliminated. So, now say, that means we have been able to get the value of x that will eliminate b. So, now say, put x equals to 3. Put x equals to 3. Are we following, please? Into the action asterisk to eliminate b. And get what? And get a. Now let's try that. Now, 6 into 3 minus 10 corresponds to a into 3 plus 1 plus b into 3 minus 3. All right? This is what? 18, because 6 times 3 is 18, minus 10, what it corresponds or equal to a into what? 3 plus 1, that's 4, then plus b multiplied by 3 minus 3, that's 0. So what happens here now? We have what? 18 minus 10 is 8, equal to 4 times a, 4a, plus 0, because b times 0 is 0. So you don't need this, it's 0. And how do you not get a? Divide both sides by what? By 4. That's 8 equals to 4a all over 4 all over 4. That is, divide both sides by this 4 to get a. So you have what? This will cancel this. 8 over 4 will be 2. So our a is what? Our a is 2. Our a is 2. So we have gotten the value of a to be equal to 2. Beautiful. Wow, wow, wow. My students have already gotten the value of a. Oh, I have beautiful students. I have wonderful students. So our a is equal to what? Is equal to our a is equal to 2. Okay. Now let's now rewrite the equation. I mean the function that the fraction that we resolve. No, initially we said that we have recall. We have a all over what? A all over x plus 1 plus b all over, I think, x minus 3. Okay? So that will now become what? Our a is what? 2 all over x plus 1, then plus our b is now equals to 4 all over x minus 3. So this is the result of the problem. 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 So I want to believe that we understood this. If you understood this, please say yes, say yes, say yes, I understood. Say yes, I understood. I want to hear from you. Type yes, type yes. If you understood it, type yes, type yes. Type yes, type yes. Okay. Type yes. Oh, thank you very much. I love you too. I love you too. I love you too. So let's continue. Let's try another question. Let's try another question. Now, let's try another question. This is another question. We are asked to resolve. We are asked to resolve. I hope we can see this second question. Okay, let me write it for us to see clearly. Resolve. Can you see the question? Okay. Resolve x cubed minus x squared minus 4 all over x squared minus 1 into partial fraction. We are asked to resolve this into partial fraction. Now, we need to be careful here. We need to be very, very careful here. Why? Good. The first point of call for us before we could resolve any problem into partial fraction is to look at the denominator. What is the nature of the denominator? The nature of the denominator here is our denominator here is what? It's a quadratic factor. It's a quadratic factor. And one of the rules of partial fraction, particularly that rule 2, says that if the denominator of our partial fraction is quadratic in nature, then we have to introduce an element of what? An element of a constant together with a linear expression. Now, x squared minus 1 is a factor. It's a quadratic factor. And at the same time, x squared minus 1 is what? It's a difference of 2 squared. We can break x squared minus 1 into x minus 1, x plus 1. Yes. If we do that and we now introduce 2 constants, we are going to run into trouble. We are going to run into trouble. We can't use that. We can't use that method. Yes. You might be saying, but sir, we can factorize x squared minus 1 and get x minus 1 into x plus 1. That would be wrong. Since the second rule says that if the degree of the denominator is equal or less than the degree of the numerator, then we carry out a division. That's what we are going to do. So we are going to divide first. Okay? Now, this is what I'm saying. Now, first, we divide. We use long division method. Long division method to divide the numerator by x squared minus 1. So let's use long division method to divide the numerator by x squared minus 1. Okay? Now, I think this board might not take it. The space is not enough to work with. So let me clean all this so that we're able to use the space that is left behind effectively well. Okay? Now, let's write the question. We want to use long division method. Want to use what? Long division method. Can we see this? Can we see this? Can we see this? Okay. Well, don't mind the straightness of the something. It is the position of the board that is not in alignment there. So we have x cubed minus x squared minus 4. We then write what? X squared minus 1. Yes. That's the first thing. Now, in this is the polynomial. This is the divisor. We are going to get a quotient and a remainder. Now let's pick the first term here. We are picking x cubed because it has the highest degree of what? Of x. And this divisor has the highest degree of x as 2. So pick the one that has the highest degree of x. So we have x cubed all over x squared. Okay? Now, if you divide x cubed by x squared, obviously x cubed means x times x, while x squared means x times x. This cancels this. You have one x left, so you write x here. Now, multiply this divisor by this x. Oh yeah, let's do like this. X, like saying x into bracket x squared minus 1. X times x squared is what? X cubed. Then x times minus 1 is what? Minus x. Please, are we following? Are we following? Okay. So, now, having done that, the next thing is now to subtract the value you obtain here from the value up here. Now, by the time you now use the subtract, you introduce minus sign. The minus sign you introduce here will affect the sign here. So this one will now become plus. Yes, because minus plus minus is plus. Now, x cubed minus x cubed, it will be 0. Then what do you have left here? You have what? Minus x squared, then plus x. I hope we are following, please. Minus x squared plus x. Are we following? Good. Good. Now, what happens here is we are left with minus x squared here. We have x squared here. So now divide this minus x squared by the x squared here. Just like we did when we started our division. Because the highest degree of x here is 2. So now have minus. You have to introduce because minus is there. So you must not abandon it. You must not leave it out. Divided by x squared. So x squared here 1, x squared here 1. So everything is what? Minus 1. So you have minus 1 there. Now multiply this x squared minus 1 by minus 1 again. Minus 1 times x squared minus 1. All right. Good. Minus 1 times x squared, that's minus x squared. Good. Minus 1 times minus 1, that's plus 1. Beautiful. Just like we did for the first one, we introduce minus sign and subtract the one below from the one above. By the time we introduce minus sign, minus times minus become plus. Minus times plus here become minus. Yes. So now we are left with what? Minus x squared plus s squared, which we cancel out. And we also have x minus 1. Yes, x minus 1. And we have minus what? Minus 4. Yes, because we have to bring this 4 down. Yes, that's the rule. You must bring it down. You must bring it down. Because 1 and 4 are numbers. They are natural numbers. So they are similar. So you bring it down. So this one will give us what? Obviously, we have x minus 5. Yes, because minus 1 minus 4 is what? X is minus 5. So we have gotten what? We have gotten x minus 5. Now, going back to our divisor. Our divisor is x squared minus 1. Our remainder is x minus 5. We are stopping it here because you cannot say x all over s squared. When your divisor, the remainder has a degree less than your divisor, you have to stop it. You have to stop it. So in other words, what I'm saying in essence is that we stop at x minus what? Minus 5. Okay? Now, how do we now write out our answers? How do we write out? The answer I'm talking about here is not the final answer. No, not at all. Now say that. Therefore, we have, that is, the product of our division is now what? This is the quotient. X minus 1. You know this is plus x minus 5 all over x squared minus 1. Yes. That is now the new fraction. The new fraction that will be what? That will be resolved into partial fraction. So we have decomposed the previous fraction into the new one. We have created a new one from the old one. So let's see how we are going to resolve this into partial fraction. Let's see. Now we resolve. Now, which of these item now are we going to resolve? Which of this item are we going to resolve? Let me write it properly. Let me write it well. Now, we resolve. Now, the one we are going to resolve is the one that is fraction. The one we are going to resolve is the one that is a fraction. That is x minus 5 all over x squared minus 1. Okay? This x minus 1 is not a fraction. It's a linear expression. So we don't have to, we don't ignore it. No. We don't have to do anything with it. It's not a fraction. Now we resolve what? X minus 5 all over x squared minus 1 into partial fraction. Yes. That's what we're going to resolve now. Okay? Now, don't let us forget, let's just write it somewhere. X minus 1 plus x minus 5 all over x squared minus 1. Okay? Now, that is what we're going to resolve. Now, looking at the denominator of this fraction, we are, like we said earlier on, it's a quadratic expression, it's a quadratic denominator, but it can be factorized because it's a difference of two squares. So recall, x squared minus 1 is what? X minus 1, x plus 1. We call the difference of what? Difference of two squares. When you have difference of two squares, that is how you are going to break it. Just like if you have x squared minus 4, it will be what? X minus 2, x plus 2. That's it. Therefore, we now have x minus 5 all over x minus 1, x plus 1. That is what we want to resolve now. Yes, because we are going to replace x squared minus 1 with x minus 1, x plus 1. Okay? Please, are we following, please? I want to hear from you. Are we following? Hope you are following, please. Let me hear from you. Are we following? All right. Thank you very much. Thank you. Now, if we are actually following, what next now? The next thing now is to what? Is to look for the constant that will stand for x minus 1 and x plus 1. Since we have two linear factors, x minus 1, x plus 1, how many constants are we going to use there now? Yeah, please, I want to hear. How many constant are you going to use there? Yes. How many constant will represent that new fraction? How many constant? Tell me, please. 2. Yeah, very good. Wow. Thank you very much. Thank you. So this now what is equal to or equivalent to a all over x minus 1 plus b all over x plus 1. Okay? So that's the constant. That's the constant we are going to use. Now, we find the LCM, just like we did in the previous one. Our LCM is what? X minus 1, x plus 1. Okay? Now, don't waste your time, like I said. Just cross multiply this. We have a into x plus 1 plus multiply this by this b into x minus 1. All right. Let's continue. So now we rewrite this as, don't forget this is x minus 5 all over x minus 1 x plus 1. So let's rewrite now. Let's rewrite. So we just need what? Denominator now. We have x minus 5. That's what we need now. X minus what? X minus 5. Please, are we following? Let me write it. X minus 5. Will now be correspond to a into x plus 1 plus b into x minus 1. Just like we did in the first example, let's now use what? Cover up method to eliminate a and what? And b simultaneously, so as to get what? B and a respectively. Okay? Now, what are we going to use here to get a eliminated? Just to eliminate a here, x will be minus 1 because minus 1 plus 1 is 0. And to eliminate b here, x will be 1. So that 1 minus 1 will be 0. How? If you are still confused here, equate x plus 1 to 0. Say x, let x plus 1 equals to 0. This one. So you have x be 0 plus 1. When it comes out, come minus 1. X will what? Minus 1. So when you put x equals to minus 1 here, everything here becomes 0. Okay? So now can call this one equation asterisk. Put x equals to minus 1 into asterisk. So we have minus 1 minus 5. A into minus 1 plus 1 plus b into minus 1 minus 1. This minus 6, because minus 1 minus 5 is minus 6, is equal to a into 0 plus b into minus 1 minus 1, that's minus 2. Okay? So this is 0, everything here is 0, so we have, it implies minus 6 is equals to minus 2b. Everything here is 0. So b times minus 2 is minus 2b. Well, how do we get b? Now say, divide both sides by what? By minus 2. Minus 6 all over minus 2 is equals to minus 2b all over minus 2. Is that clear? Okay. So minus 2 will cancel minus 2. Minus will cancel minus, that's plus. 2 in 6, that's 3. So b is equals to what? Is equals to 3. So let's write down somewhere. B is equals to 3. So we have gotten b to be equals to 3. So now going back to the equation. Now going back to this equation star. Going back to equation star or asterisk. We need to what? We need to eliminate b now to get a. When we eliminated a, we got b. So for us now to get b, we eliminate what? Okay, for us to get a, we now eliminate b. Now, to eliminate b, that's x minus 1 b equals to 0. So x equals to 1. So now say put x equals to 1 into equation asterisk to eliminate what? To eliminate b. What is the essence of eliminating b? In order to get a, we want to eliminate b so as to get a. Okay? Oh yeah, let's try that. Oh yeah, 1 minus 5 A into 1 plus 1 plus B into 1 minus 1. 1 minus 5 is minus 4 equals to A into what? 1 plus 1 is 2 plus B into 1 minus 1, that's 0. So that implies minus 4 equals to 2 times A is 2A plus B times 0 is 0. So you don't need to bother yourself. You don't bother yourself about that. You don't need to, because B times 0 is 0, so you don't need to write that again. So now do we now get A? You divide both sides by 2. So now what? Minus 4 all over 2 is equals to A. That implies minus 2 equals to A. That means minus 2 is equals to A. All right. So now we have gotten A, we have gotten B. Now, the final thing now is to write the equation. The final thing is to now to write the equation. So A is minus 2. A is minus 2. So let's write the equation. Remember? Therefore, the partial fraction x minus 1 plus x minus 5 all over x minus 1 x plus 1, which was equal to x minus 1 plus which one was over x minus 1? It was a all over x minus 1 plus b all over x plus 1 is now equal to, this is the fraction we later got after the long division. So we're now going to write everything out, and don't forget x minus 5 over this is the only one we resolve into partial fraction. We didn't resolve this, so that's why we are writing it back. X minus 1 plus, and this one, the constant for x minus 1 is a, the constant for x plus 1 is b. So this one, well, we got what? X minus 1 plus, what did we get for a? We got minus 2 for a, minus, so plus times minus is minus 2. So minus 2 all over x minus 1, then plus, what did you get for b? 3 all over x plus 1. If you write your answer like this, is correct, or better still, it's the same thing as what? X minus 1 plus 3 all over x plus 1. If you want to write this version first, then minus 2 all over x minus 1. What is important is that the value you obtain for b must not change, because b was the one that takes x plus 1 in your calculation, while a takes x minus 1. So that is the solution of that second problem. That is the solution of that second problem. Please, do you understand? Do you understand? Please, do you understand? I want to hear from you. Are we following, please? You are not talking here. Okay. All right. All right. Okay. Okay. Now, let's look at another question. Let's look at another question. Let's look at another question. Now, we are going to consider all the questions that are relevant to the rules, so that we understand the rules better. Let's look at another question. Okay, this is another question. Resolve. This problem 3. Resolve x squared plus 4x minus 7 all over x plus 1 into bracket x squared plus 4 into partial fraction. Resolve that into partial fraction. Resolve that into partial fraction. Okay. Now, this is another very interesting question in partial fraction. Before you could solve any question in partial fraction, you have to consider the denominator. Ask yourself, which of the rules is applicable here? You have to ask yourself, which of the rules is applicable? You don't jump into conclusion. Let's look at our denominators. The first denominator here is x plus 1, which is linear. So rule 1 will take care of that. But the second denominator is a quadratic factor. So what happens there? What happens there? That is another rule. That's, you see, because the last one, the last question we just solved now, does not talk about quadratic denominator. So that means we're going to apply rule 3 here. Whenever your denominator is quadratic, you have to break it in the form of quadratic expression. How? Fine. Let me remind us. If you have a denominator like x squared plus a, yes, you have to break your numerator, the constant, as ax plus b all over that x squared plus a. Yes. Take note. Take note. Take note. Yes. That is how to do it. When your denominator has what? Has that expression, that is how they're going to write it. Okay? Because x squared is a quadratic factor. A here is a constant, which is represented by 4. You can't factorize x squared plus 4 and say x plus 2 squared. No, that will be wrong. So you cannot factorize this. Since you cannot factorize this, you cannot break it down into linear factors, then you have to comply with the rule of the rule 3 that talks about quadratic denominators. So let's solve this. Let's solve this. How do we solve this? Fine. Solution. Now we have, remember, the first factor in the denominator is what? Is linear. So we have x squared plus 4x minus 7 all over x plus 1 into bracket x squared plus 4 will now correspond to a all over x plus 1. Yes, because the first factor is linear. So we take constant. Plus, we can't take a again. So it will now be b. bx plus c all over x squared plus 4. You know, I just told you now that if it were x squared plus a, you're going to write it what? In form of ax plus b all over x squared plus a. But since we have used a for this x plus 1, so the next constant will be bx plus. At least what you are saying is that for any quadratic factor, 2 constants will be used. And the 2 constants, one will take x, the other one will not take x. That's the standard. That's the rule. Check it again. Check it again. Check it again. That's how it is done. That's how it is done. That's how it is done. Suppose we have another, let's say we have another linear factor here. I'm just assuming, suppose this is x plus 4, and we have now x squared plus 6 here. So after a over x plus 1, this one will be what? B over x plus 2, x plus 4. This one will not be what? Cx plus d. Because you have used a for this, you have used b for this, the next one will now be cx plus d. So that's how it will go. It's just an assumption, okay? So let's go back to our question. So without wasting our time, let's find the LCM. The LCM is what? X plus 1 into bracket x squared plus 4. Like I told you, once you are multiplying them, just cross multiply to get your values out. A into x squared plus 4 plus the whole of this times this, x plus 1 into bx plus c. Yes. So that means this is what? This x squared minus 4x, plus 4x minus 7 all over x plus 1 into x squared plus 4 is this. Okay? Now, we ignore the what? The denominator. So now use our numerator. So let's what? Let's ignore the numerator, the denominator, and make use of numerator. So we have x squared plus 4x minus 7, now equivalent to a into x squared plus 4 plus x plus 1 into bx plus C. Are we following, please? I hope I'm not doing it myself. Please, are we following, please? Are we following? Please, I want to hear from you. Are we following? No. Hello. Okay. Are we? Oh, thank you. Thank you very much. Thank you very. God bless you for answering me. God bless you for replying me. So, that is that about that. Okay. Now this time around, let me explain. We have to be careful here. We have to be careful. The best approach here is not by cover-up method, because cover-up method will not work effectively well without using expansion there. Yes, I can assure you. And I can show you. It can work for this, but it do not work for this, because the square of a negative number is positive. So there's no way you can make this one, except if you want to talk about plus or minus, and we don't need that here. Even if we talk about plus or minus there, if you say x is plus or minus 2, minus 2 square is 4, so it will not work. So what we just need to do, since cover-up method will not work here, it will work for this. So by the time you put s to be minus 1 here, everything here will be 0. But let's just take a straightforward approach so that it will not waste our time. Now let's expand everything. Expand. We have x squared plus 4x minus 7 equals to as squared plus 4a plus, now we are expanding, x times bx squared, x times plus c cx plus 1 times bx plus bx plus 1 times plus c. I think that is good. Now, the next thing we are going to do now is we are now going to consider coefficient of, now compare the coefficients of s squared, x, and constant terms. We want to consider the coefficient of s squared, x, and constant term. Why? Good. You will see the reason now. Let's look at the left and right hand side. To the left hand side, which numbers have s squared? This is s squared. We have s squared here. Oh yeah, we have s squared. There is no s squared again. It corresponds to as squared. Good. Correspond to plus bs squared. Good. No s squared again. So that means if s squared, which is common to them, is used to divide all of them, this one will be 1 equals to a plus b. Let's call this one equation 1. Good. Now we have considered the coefficient of s squared. Let's consider the coefficient of x. Those that have x. Oh yeah. You have plus 4x. Now let's say 4x. We have. Please, are we following? For x we have plus 4x here. No one with x again. Equals to 6cx plus bx. Yes. So if we divide through by x here, we have what? 4 equals to c plus b. That forms equation 2. It's getting more interesting. It's getting more what? Interesting. Now let's look at the constants. Let's look at the constants. The one without x at all. For constant terms, we have, with this place, take the constant. Let's try. Minus 7 on the left hand side. On the right, we have 4a. There is a constant. Plus c. That's equation 3. Wow. We now have 3 equations. Here you have to be careful so that you don't run into trouble. We have to be careful. We have to be careful. Now. The first equation has a and b as constant. The second equation has c and b as constant. The third equation has a and c as constant. You can see that for equation 1 and 2, b is common. But for equation 2 and 3, c is common. Well, it's a very simple thing. We might decide to
to make B solve the formula here and put B here. You know, B is not in equation 3. By the time we get B to be something here, I will now put it in equation 2. B will disappear. We have A left, and so we now compare equation 2 and 3. Okay, let me show you what I'm talking about. Let me show you what I'm talking about. You get it now. Don't worry. Now, in equation 1, or we can say from equation 1. Maybe from equation 1. From equation 1. Now, 1 minus A is equals to B. Can call that one equation 4. Yes. If you make B, so that is, you transfer A to this side, it will be 1 you know, A is positive. By the time it crosses this equal to side, it comes here, it becomes minus. Good. Now say put equation 4 into 2. Don't be confused. I will show you. Let me write them somewhere so that I will not have issues. 4 equals to C plus B. Minus 7 equals to 4A plus C. So we have 2, we have 3. I've written them somewhere. So I won't have issues. I will not have issues. I will not have issues. Oh yeah, let's go. Fine. Let's go. Want to put 4 into 2. And 2 says 4 is equals to C plus B. Abi? So that means, and 4 says B is what? B is now 1 minus A. So wherever you see B, write 1 minus A. So we have 4. Let me now implies 4 equals to C plus 1 minus A. Good. Of course, because our B is not in B now, will no longer be B. It now be 1 minus A. It's just like simultaneous equation where you have to substitute. You use substitution method. You know, 4, we got 1 minus A from equation 1, we got 1 minus A equals to B. We are now putting it there in equation 2, that where we see B, we should not write B again, we write 1 minus A. That's what I did. So this one implies what? 4 minus 1 equals to C. What happened? C minus A. Don't let us get it wrong. Because when minus 1 comes here, it becomes what? When it is plus, yeah, when it comes here, it becomes minus. 4 minus 1 equals to C minus A. Which means what? 3 is equals to C minus A. So let's call that one equation 5. And what is equation 4? Equation 4 is what? Minus 7 equals to 4A plus C. That's equation 4. Don't be confused. It's easy. Come on, it's easy. So now let's rewrite equation 4 and 5. Rewrite equations 5 and 4. Oh yeah, as we want to rewrite them so that it will be easier for us to solve, to work with. Equation 5 is what? You can have C minus A is equals to 3. So C is coming up as the first element. So equation 4 will be C plus 4A equals to minus 7. Yes, now. If I want to write C first, so that my elimination will be easy. Are we together? I just rewrite. You know, I didn't change anything. When you are taking everything from the left to the right, that's when it will change to, the sign will change. But when you are just changing directly everything, there won't be any problem. So now, I can say that, let me subtract equation. Remember, this is equation 5. This is equation what? Equation 4. Now, having done that, let me write it somewhere. B is equals to 1 minus A, because I will need it later. Now, the next thing is subtract equation 4 from 5. Oh yeah, subtract equation 4 from 5 gives oh yeah, C minus A is equals to what? 3. Good. Then we are subtracting minus C minus 4A equal to what? Equal to 7. Why? How? No. Don't get it wrong. You are subtracting. We want to, why we are using subtract equation 4 from 5 is because we want to eliminate this C. And it's not easy to eliminate C like this because both of them have they all both have positive sign. You can't eliminate variable that have the same sign. No. Thank God they have the coefficient of 1. There's 1 here, 1 here. But plus 1, you can't eliminate them. You can only eliminate when one is plus and the other one is minus. So that's why we say subtract equation 4, the one below, from the one above. And when we now introduce, when we say with that statement, it means minus will be here, and minus will multiply, we change all the signs across. This one will be minus, this plus as minus, minus, plus minus as minus is plus. That's why you have plus 7. So from there now, C will cancel minus C. With that C has cancelled minus C, what follows here? What follows? Minus A minus 4A, that's minus 5A is equal to 3 plus 7, 10. So, how do we get A here? Divide both sides by minus 5. So, A will be 10 all over minus 5. So, plus times minus is minus. 10 over 5. 5 here, 1, 5 here, 2. So, 2. Therefore, A is equals to minus 2. We have gotten A to minus 2. We have gotten A to minus 2. We have gotten A to minus 2. Please, I hope you are following. We have gotten A to what? Minus 2. Now, how do we now get B? If A is minus 2, how do we get B? Let's check that. If A is minus 2, how do we get B? Obviously, since B is equals to 1 minus A, then B will be equals to 1 minus, what is our A? Minus 2. Of course, because our A is minus 2. So that will be what? B will now be equals to what? 1 minus as minus is plus 2, which is 3. So B is 3. B is 3. We have gotten A. Let me write this somewhere. A is minus 2. B is 3. Now, how do we get C? Wow, so simple. Remember, in one of the equations, is it equation 2? C from equation 2, I think, is it 2? Oh, 3. I think it's 3. From equation 3. 4 is equals to C plus B. Abi? You want to check? That's what we have in equation 3. And now to get B, to get C, that'll be 4 is equals to C plus our B is what? Is 3. So collecting like term gives what? 4 minus 3 is equals to C. And what is 4? Because plus 3, when it comes here, it becomes minus. So 4 minus 3 equals to C. So 1 equals to C. So our C is 1. Wow. Our C is 1. Our C is 1. So what next now? Let's now write out all the equations. I mean the fractions. Let's write the fractions out. Can we still remember this? No. Well, let's check. You can still remember what the fraction is. I think we recall. We have that. We have that. A all over, I think that's what we have. X plus 1 plus bx plus c, yes, all over x squared plus 4. I think that's what we have. Okay, that's what we have. So let's put them there. C is 1. So let's now put them there. Let's put them there. So let's put them there. Let's substitute. By substitution now, so what do you have? Thus, the resolved partial fraction is, our A is what? Minus 2 all over x plus 1, then plus our B. Our B, we got 3x plus our C is 1 all over x squared plus 4. This is the answer. If we like, might start with the positive one, or we can say 3x plus 1 all over x squared plus 4, then minus 2 all over x plus 1. What is important is we must not make mistake of putting the values we obtain for A and interchange it for B. The moment we mistake those values for each other, then we have run into trouble. So that is that about the question number 3. That's about the question number 3. Can we quickly do number 4 before we move on to another topic, please? Should we quickly do number 4 as well? If you want us to solve question number 4, let me hear from you. Please type yes. Question number 4. Question number 4, which rule 4. Should we continue with question number 4 here? Question number 4. Hello, students. Are we there? Please type yes if you are there. If you are still there, type yes. Type yes. Hello? Are you still there? Are you still there? I want to hear from you, please. I want to hear from you. Do you have questions concerning the one we have just done now? Should we continue, please? All right. Should we continue? Question number 4. All right. Let's attempt question number 4. This is another question. Resolve 7x plus 2 all over 2x minus 3 into x plus 1 all squared into partial fraction. This is another question. If you are still there, please type yes. If you are still there, type yes. If you are still there, type yes. If you are still there, type yes. Was there network problems? If you are still there, type yes. If you are still there, type yes. Please. Hello? Are we together? Please? Okay. Let's resolve this into partial fraction. Now, this particular question, which is question number 4, has application with respect to theorem 4 or rule 4. If you look at the denominator, you observe closely that we have a linear denominator, and we equally have what? A repeated denominator, because there is a square on top of one linear denominator in the denominator. Okay, so with that at all, that implies that we have to use another rule. Rule 1 will not apply here. It will never apply here. If we use rule 1 here, rule 1 can only apply with respect to, it's only applicable to 2x minus 3, but for x plus 1 raised power 2, root 1 is not applicable. Okay? It seems the network is gone. Because
I think I can't receive signal. I can't receive signal from my students again. And nobody is talking here. The network might be gone. Network might be gone. Network might be gone. Wow, network is gone. Hello? It's quite unfortunate.